So let's take a look at trigonometric integrals that are integrals that have trig functions in them. And sometimes they look really tricky to do, just like this one. Sine cubed x times cos to the 4x dx. And you might not have a clear path of how to do this. When it comes to trigonometric integrals, your goal is to always make it into one trig function. Right now we have sine and cos. Our job is to somehow convert this into just one, into either sine or cos. And this is what I'm going to do. I'm going to say, first let u equals to cos x. And then du by dx is going to be equal to negative sine x. And it seems like negative du is going to be equal to sine x dx. So let's leave that for now, and I'll show you exactly what that's going to be useful for later. Now, the whole thing about converting these into one variable is to just choose one, and then we have sine x, and then this is sine x times sine squared x, and using the basic Pythagorean identity, this becomes 1 minus cos squared x. And the reason why this works so beautiful is because if we were to go like this, d of x, we know that d of u is going to be equal to sine x d of x. So this sine x and this d of x can be replaced directly inside. And then everything that is cos x can be replaced with u. So this would become 1 minus u squared times u to the 4 times negative du. So it works out very, very conveniently. And at the end, you get an expression with just u's, which is very easy to integrate. So this becomes negative u to the 4 plus u to the 2 d of u. I'm just going to get rid of this negative here. So it becomes u to the 4 minus u to the 2 d of u. And this becomes 1 over 5 u to the 5 minus 1 over 3 u3 plus c. So of course we have to substitute back u equals cos x, so this becomes negative 1 over 5 cos to the 5x plus 1 over 3 cos to the 3x plus c. So that is how you would be evaluating this specific integral. So the integral of sine cubed x times cos to the 4x dx, just like that. So let's take a look at another neat example here. Find the integral of sine x over 1 plus cos squared x d of x. So same thing. Your goal is to convert it into just one trigonometric function. So we have sine x, we have cos squared x. We want to get rid of at least one. Here, we're going to let u equals to cos x once again, and it's going to become du over dx equals to negative sine x. And du with a negative is going to be equal to sine x dx. And we can already see the vision here. This sine x dx can directly be replaceable here. So it's kind of like an extended u substitution, but it just involves some trig functions in it. So this would become negative 1 du all over 1 plus u squared. I'm going to extract the 1 out, and you'll recognize that this is arctan u plus c. And substituting back the u, this would become cos x plus c, just like that. So the integral of sine x over 1 plus cos squared x dx equals to negative arctan cos x plus c.